In this tutorial, first we will learn basic concepts of Elasticsearch and related ones. Next, we will dive into the code, and in the first step, we will add the Elasticsearch service to our Docker Compose. Then we will add the Django-Elasticsearch-DSL package to our requirements and use it to provide search API. Then we will create a product index in our Elasticsearch. Then we will define product document on the product model. Next, we will create an API view. In it, we define the get method that gets a query and does a search. And after that, we will test the API and see the fuzziness feature of Elasticsearch. In the next section, we will use the Django-Elasticsearch-DSL-DRF package. This package is designed explicitly for the DRF package. Next, we will change our product document to have suggestion ability on our product names. Next, we will define ProductDocumentSerializer. After that, we will create a document view set. Last, you can see how easily we can do search, filter, and auto-completion by using that package. Okay, in this tutorial, I want to give a quick presentation about Elasticsearch, so we can have a base knowledge about it. First, we will speak about Elasticsearch and see what this tool is about. Then we will compare Elasticsearch with Postgres built-in full-text search. Next, we will see the main pros of Elasticsearch. Then we will see the architecture of the stack. And in the last, we will set up Elasticsearch with the Django framework. So what is Elasticsearch? Elasticsearch is a tool that helps us to search our data efficiently. So by using that, we can quickly get more relevant results, and it's designed especially for massive data. Elasticsearch is a component of a bigger stack named Elastic or ELK. This stack has three important parts. The first one is Elasticsearch, which is a search engine. The second one is Logstash, which is a server-side data processing pipeline. So you can define the different data processing pipelines and apply them to the input data. The third one is Kibana, which is used for data visualization. So you can use it for presenting your results with different graphs. So in this stack, Elasticsearch is a search engine, and it is a distributed and open source project with RESTful APIs and is scalable and other features. Now let's compare Elasticsearch with Postgres full text search. If you have experience with Postgres, you probably heard about full text search. It is an optimized search that Postgres provides for us. And in Django, you can use it easily, especially with the DRF package. As you can see in the picture, both of them have pros. And we can say that if you need a simple search and your data is not huge, Postgres will probably be pretty enough for your requirements. Okay, in this slide, I want to mention the significant advantages of Elasticsearch, so you can have more reasons to decide to learn it. It is a scalable search engine that can run over a cluster of virtual or physical machines. It can have the best performance in huge data environments. It supports about 40 languages for doing search analysis. It has a schema-less design like no SQL databases. It is an open source project and has a huge community. It also has an optimized auto-completion ability. And now let's see how it works. In the best practice, we have all three components where we have multiple sources. Their data goes to the Logstash, and after some preparation, it goes to Elasticsearch. Then we can use Kibana or for visualization of the results. However, in this code demo, we will use just Elasticsearch component for simplicity reasons. As I mentioned earlier, Elastic has a RESTful API, so we can do our search with a post or get requests. Here we can see two searches. The first one is simple and we can do it with get request. And the second one is more complex and we can do it with post request. Now let's dive into the code and add Elasticsearch to a simple Django app. Let's dive into the code. First, let me add some VS Code settings to this project. I want to use Python black formatter and do it automatically after each save. It's a good practice you use formatters in your project so coders will have a neat and similar looking throughout your projects. I also added some settings related to SFT so my codes can be run simultaneously on my remote server. Then I will add this directory to gitignore because I don't want to publish it to their repository. Then I do some sorting to the list because it also is a good practice. Okay, let me start by adding Elasticsearch to our Docker compose. I will use the latest version at the time of recording this video. I disable the security configuration to anonymous access and node discovery because we have just one node here. We also need to set the volume for this service, so its data will be permanent. Elasticsearch by default use the 9200 port, and we also use this port in the host machine. And in the last, I add volume to the list. Okay, now I should rebuild our containers. I do that by docker compose up build command. You can see that Elasticsearch also comes up. Before changing the main code, let me check list API to ensure our backend service works correctly. Okay, now I want to add Django-Elasticsearch-DSL package. This package is designed explicitly for the Django framework. We can use Elasticsearch easily in our project by using that package. Then I sort the list. Next, I have to rebuild our services because we added a new package. Now I add the package to our installed apps list. I also should specify where Elasticsearch is. Now let me create our documents.py file. In this file, we should specify our documents. Documents are similar to models. We develop models for each type of object in Django, and now for Elasticsearch, we also should do that. First, I need to import required packages like index and document. Then import our model. Now I want to create a new index for our product objects. In the Elasticsearch world, you should store your objects in the indexes. I made a product index and considered just one shard and zero replication for this tutorial. Shards are used to have parallel access to the data. So in this way, we can read data much faster. Replicas can improve search performance and for failover situation. Okay, I specify our product document on the product model and which field I want to be indexed. Next, we should do an important thing. We should always rebuild our index in the Elasticsearch whenever we make some changes to them. To do that, I'm going to our shop API container, and then using the search index command, I can quickly rebuild our indexes. Okay, we got an error that was related to a typo. I fixed the typo and rebuilt our containers. Now you can see we rebuilt our indexes. Let me create an API that gets a query and does a search using Elasticsearch. I will define a function to generate an elastic query expression. Here I will use match type query, but there are some other types that we can use like multi-match or boolean. I want to search the name field of products. And also I want to use some elastic specific feature named fuzziness. Fuzziness is a good solution where we could have typos in the search terms, and Elastic will handle it by using Levenstein algorithm. Now I define our get function. So in the request, we will have a query parameter named a query, and we do the search using that. Okay, you can see that we can search for elastic documents using the search and then query function on them. You can easily convert search results to Django query set using the toQuerySet function. Now let's create a URL endpoint for that view function. We register the path product search for this purpose. Okay, now let's test our API. Let's search bag term. As you can see, we have one result for it. Now let's imagine that the user has some typo in its query. As you can see, Elastic will handle that for us. If we remove the fuzziness config, we have no result for bag term. Now I want to use a specific package designed for DRF package. Using it, you can easily set up different filtering or search types in your APIs. In this section, we also use Elasticsearch suggester functionality, and we will see how it works. Now let's dive into the code. First, I'm going to add the Django-Elasticsearch-DSL-DRF package to our requirements, and as always, do some sort on the list. Then I will rebuild our containers. Next, I add the package to installed apps list. Okay, now I want to add suggestion functionality to the name field. I will map the name field to the name in our Django model and then add a suggest field. Then I want to use DSL-DRF specific serializer and viewset. This serializer is a wrapper around the document class, not a model class. Now I want to create a viewset class that can specifically do search and filtering on the product objects. As you can see, you can use different filterings and functionalities here. Now let me create the view set. I will add different filterings and use suggestion on the name field. Now let's connect it to a route. Next, I will test it with the Postman app. First, I want to get products whose IDs are in the set of 2 and 3. Okay, it works correctly. Now let me do another filter. I want products that are greater or equal to 200. Now I want to get products that their prices are in the range between 300 and 600. Now I want to test suggestion functionality. As you can see, it gets our query and returns most similar products to us. Thanks for watching this video. I hope it was helpful. If it was, don't forget to like it. If you want to be notified whenever a new video comes out, then subscribe to my channel. If you had any question, please post them in the comment section in the below. I will try to answer them as soon as possible.